Alrighty, so in this video, we're going to talk about how to do that other lesson 3 assignment, the dimensional analysis worksheet. And I'm hoping that this serves as just general practice for you to do dimensional analysis. I know a lot of people are still struggling with it, and it's hard. That's okay that you're struggling with it. It's hard. But we're going to break down in this video how to do that, and we're going to move through the problems so that way you can follow along, check your work, and know exactly what you're doing. So the biggest thing that I want us to grab onto for the beginning of us learning how to do dimensional analysis is you are going to just take your starting amount and multiply it by the conversion factor. Okay, your starting amount multiplied by the conversion factor. So this page is here. It gives you a nice explanation. You can go ahead and read it if you want to. You can do the practice problems, but I'm going to skip right down to the actual assignment part. And we're going to do our best to go through. I'm going to try to draw along with you guys. And okay, cool. There's a clear screen button here. So basically, how much, so it says 6.84 meters was our calculated rise in sea level if all the ice on Greenland melted. How much is this in feet? Show your work. So remember, starting number times conversion factor. So our starting number is 6. Let's see if I can use my finger. 84. Oh, perfect. Yeah, let's do this. Meters. And remember, I don't think it says it in the part above, but I want you to get used to doing this because I think it's going to help a lot of you visually. That's going to be over the number 1, over 1, and then times our conversion factor. So our conversion factor is right here, and it's 1 meter equals 3.28 feet. Now remember, you want the units to cancel out the units that you start with. So in this case, meters. You want them to cancel out. So they need to be on opposite sides of, diagonally from each other. If one's on the top, the conversion factor, it's got to go on the bottom. So here, that 1 meter is going to go down on the bottom, and then that top is going to be the 3.28 feet. There we go. And congratulations, you've set up your dimensional analysis. I know that there's a shortcut, easy way to do this, but it's really going to become helpful when we start having lots of conversion factors later on. But anyway, to finish solving this, you multiply everything on the top, multiply everything on the bottom, and then divide the top final by the bottom final. The top number is 6. I told you I'd use a calculator. Let me pull it up. So our top number is 6.84 multiplied by 3.28, which is 22.43. I'm just going to say 22.4. And the reason that we don't really need to divide it by anything is because 1 times 1 is 1, and anything divided by 1 is just itself. So our final answer here is 22.4, and that's in feet because that was the point of what we were doing. We're trying to convert it. So let's go down. Oh, that totally throws that off. Let's go down to number 2. Would this cover up a house currently at sea level? How much is this in terms of stories / buildings? So again, starting number times conversion factor. Our starting number that we just calculated was 20. Let me use the pen. What did I say? 22.4 feet over 1 multiplied by the conversion factor, or in other words, how many feet are there in a story? 14. Remember, we want it to be diagonal so that those units cancel out. So down here, 14 feet, and that equals 1 story. Multiply everything on the top, multiply everything on the bottom, and you ultimately get, I know it's going to go in the lines, but you get 22.4 divided by 14. And that is going to give you, I don't remember what it is off the top of my head, 22.4 divided by 14, 1.6. So that's 1.6 stories that we just converted to. Good job. Okay, let's clear this again and go down and do number 3. I don't know if it's Maldives, I'm ignorant, is a group of islands in South Asia situated in the Indian Ocean. It lies southwest of Sri Lanka and India, about 700 kilometers or 430 miles from the Asian continent's mainland. It is also a popular tourist location known for its beauty and coral reefs. That stuff's not important for our math. The population density is 1,802 people per square mile. How many people is that per? I'm so sorry. 1,802 people per square kilometer. How many people is that per square mile? So we know, where does it tell us? We have to do kind of a few different steps here. So we're going to start with the fact that we know that 1 kilometer is equal to 1.609 miles. Okay. And we're talking about kilometers squared and miles squared. So we kind of need to figure out how many square kilometers is equal to a square mile. So if we were to square both sides of this little equation, we would get that 1 kilometer squared, because 1 times 1 is just 1, is equal to, and where'd our calculator go? Clear everything. 1.609, not divide, times 1.609 is equal to 2.5, well, let's say 2.59. So 2.59 miles squared. Oops. Awesome. So I'm going to scroll up just a little bit. So we know the population density is 1,802 people per square kilometer. So I'm going to go over here on the right, or the left, is one. Why did it not let me use the pen? 1,802, and that's people per square mile. So people divided by, I said mile again, square kilometer. Okay, and now we're trying to figure out how many square kilometers, like how much that is in miles squared. So this one you're doing it a little bit different because our conversion factor, that like what we're trying to convert, is on the bottom. So normally when what we're trying to convert's on the top, and we put that conversion factor so those same units are on the bottom, now it's going to be flip-flopped. So 1 kilometer squared, if we go up here, 1 km squared is 2.59 miles squared. If we were to, and we know that, well, so what we're trying to get is people per square mile. So what we can do to know that we're done is cancel out kilometers squared. Oh, look, and we've got people on top, square miles on the bottom. So if we were to do all of this to like 1802 divided by 2.59, clear everything. 1802 divided by 2.59, that is equal to roughly 696 people per square mile. 696 people per square mile. let's hop back down here. We're going to clear all that. And we're going to do this last question. So this place is currently 72 inches above sea level. Is this more or less than 5.1 meters? Use a unit conversion of 39.4 inches per 1 meter. What will happen to this place if Greenland melts completely? So let's take our starting number. Come on, pen. 72 inches over 1, because it doesn't give us a per something. Inches are on top over here, so when we enter our conversion factor, the inches is going to be on bottom. So 39.4 inches is equal to 1 meter. If we were to calculate that, let's throw up our calculator. 72 divided by 39.4 is 1.8. So basically 1.8 meters. So the second half of that question is saying, is this more or less than 5.1? Well, is 1.8 more or less than 5.1? It's less, right? So if we go down here, let's clear that and just remember that we got a 1.8 meters. Basically, a house at sea level, yeah, it's going to sink because it's at sea level, right? It's at 0 meters. And if the sea level was to rise 1.8 meters, then yeah, they're going to be underwater. But these people here, I believe it says they're 5.1 meters above sea level. So are they going to be affected by a 1.8 meter rise? No, they're further above sea level than this sea level change. What would happen in these situations if Greenland melted only 25%? You would take 25% of whatever, this 1.8, which again, you can either divide by 4 or you can multiply by 2.5. It doesn't matter. And you get that that's 0.45 meters. So again, a house at sea level, yeah, they're going to be underwater because they're originally at 0 meters above sea level, where these people here that we're talking about, they would be totally fine because, well, they're 5.1 meters above sea level. So anyway, that's how you do this worksheet. I know that was a little bit of a long video. Thanks for hanging in there, and good job.